causes of river degradation. This is the fun bit, describing how we are a stuff up as a species. So all human activities degrade ecosystems, pretty much. So basically everything we do has a negative impact on ecosystems. And in itself, we learn to live with that. We learn to minimize those impacts, hopefully. But the critical issue with environmental degradation is duration of the impact and thresholds. And again, I'll use an agricultural analogy. Up to about 30 years ago, most of the wheat was produced with sheep wheat farming. So basically, you'd grow wheat for a couple of years, then let the grass come back in, put sheep on for a few years, then you grow wheat again, then you have sheep, and that was cycling the nutrients. It would allow the carbon to build up in the soil. The sheep dung was good for the soil. Nutrients would come in from the bedrock and coming through dust, and so basically you could do that in perpetuity. And now we've moved to a system where you grow wheat every year and you've got to fertilise. So the inputs have to match the outputs. And it's a lot with ecological degradation too. You can degrade an ecosystem to a certain threshold and it will always pop back and recover. That's what you call ecosystem resilience. And a good example is sustainable forestry. You can go in and cut a certain number of trees on a certain cycle and you're not going to lose any species. It might look a bit different. You might not have the huge trees anymore, but you're not going to lose any plant species. You're not going to lose any animal species. That's different to clear felling, and you fundamentally change the landscape. Now, same with rivers. The things that have impacted rivers are the duration of impact and the intensity of impact. And once it reaches a certain threshold, you end up with catastrophic change. So it can't pop back easily to what it was like before. And so we've done that very much with rivers. The main reasons for that degradation is land clearing. Through clearing the land, we have allowed banks to erode. Through land clearing, we have stopped water being held back in the landscape. So even in landscapes like this, it's not just the rivers. Clearing up in the hills means that we've actually allowing water to flow across the landscape faster. So instead of falling on trees' leaves and getting put into the soil, it's flowing across the surface. And so water is entering rivers faster and not being kept back in the landscape. A mature eucalypt in a sort of 10-15 mil rainfall event can put anywhere between 700 and 1,000 litres of water into the soil, just falling on the leaves, running down the branches and down the trunk into the soil. Take that tree away, that 700 or 1,000 litres of water is going across the surface. Some soaking in, but it doesn't have that mechanism to pump it into the groundwater. And so what that's done is two things. One, water enters the rivers faster, which means it has to get away faster, which means there's more erosive power, but also means that your landscape dries out faster. And it has been a tenet of land care for 30 years that getting trees back in the landscape, the average, they say, is you can revegetate 10% of your farm without losing any productivity whatsoever. And in some cases, you can do 20% of your farm and not lose any productivity because you're adding shade and water back up the hill. So the clearing has impacted the flows of water. Clearing has also allowed for banks to be destabilised. So we get things like erosion and slumping. Clearing has also stopped animals from moving along the river corridors. It's also stopped advantage of animals coming down to the river corridors for food. So again, disrupting ecological cycles. It's also affected the in-stream habitat. Something like 90% of the food that fish eat comes from falling fruit and leaves. And so if you don't have any overhanging vegetation, there's not that immediate food source for fish. And while they might be able to survive in some areas where there is vegetation, we've got the added problem of the extra flows makes it harder for fish to live in the river because we're just flushing them out. There's too much pressure, literally and metaphorically. So clearing riverbanks and landscapes has also impacted the aquatic habitat. Another way clearing has impacted the aquatic habitat is letting more light in. So that does a couple of things. Having more sunlight reaching rivers means the water gets hotter, and so it can get above the thresholds for certain organisms to be able to live well. So certain fish, they like cooler water, they like shade. Having more light and more warmth in the river, and because we've got a lot more nutrients in the river because the banks are eroding and mobilizing all those nutrients, we often get algae blooms in rivers. And so when there's algae blooms, that can actually pull all the oxygen out of the water. We call it BOD, or biological oxygen demand. And so so having all that algae grow and then die, it can basically kill fish. At the worst case, you get a lot of organic matter washing down, and that causes what's called blackwater events. And you've probably heard about those happening in the Murray River. And that's usually where a whole lot of organic matter that's sitting on the banks gets put into the river, and as it rots, it takes out all the oxygen and everything dies. So that's all because of clearing. One thing I've meant to say, there was actually ecological change pre-European as well. So we shouldn't just think that the environment was a static thing before Europeans came to Australia, and that we've just totally stuffed it up. The environment changed significantly over thousands of years because of human interactions. Even Aboriginal communities changed the environment as well. But their impact level was lower, the population was lower, and so a lot of their changes were low-level impacts over a long period of time. And their technologies changed. Fire was really only introduced in the last 3,000 or 4,000 years as a regular tool in landscapes. There's a lot of evidence along the east coast from wetlands and swamps and lakes where they can actually bore down into the sediments. They can actually see the frequency of fires and how intense those fires were. And also from those sediments, they can actually see what pollen is in those cores. And so at any period of time, they can go back and say, well, okay, 3,723 years ago, there was a lot more of these species or that species growing here. And if there was a lot more rainforest species, it would indicate lower fire frequency. If there was a lot more things like grasses and eucalypts, shows there was a higher fire frequency. So we do know that fire has been relatively recently introduced into the landscape, but that has had significant changes right across the east coast. A lot of rainforest has disappeared, and more eucalypt forest and more grasslands along the east coast because of Aboriginal burning. Now, again, I get back to the point of thresholds. That impact was over time, and even though it was monumental changes, it was at the pace that the ecosystem could adapt. What we've done as Europeans is change landscapes and landscape function so fast that things haven't had a time to adapt, and so that's why we have big problems now. And a lot of what we do through land care is slow down the pace of change, and get back beyond those thresholds so nature can repair itself. Agriculture has had impacts on rivers, so clearing for agriculture obviously, but also we talked a bit before about cattle going down to riverbanks. I'm sure you've all seen parts of the Hunter where cattle come down. You can see the paths going down, and then they collapse and they take new paths down. Allowing livestock down to rivers does two things. It stops regeneration, and it creates conditions where erosion and mass wasting, slumping, can happen more on the riverbanks. It also affects the in-stream habitat because cows will crap anywhere, and having a lot of cow crap right in the river is making rivers more nutrient rich, which can then lead to algae blooms. There's been a lot of extraction of sediments, sand and silt, for horticulture or for construction. There has been some in the Hunter. There were extraction licenses, and what that does, it fundamentally changes the river as well. If you're having what they call dredge pools, if you have a river bed and then suddenly there's where it's dredged, you end up having deeper water, the water flows and creates turbulence. And what happens, those dredge pools actually move upstream. So if you imagine there's a pool here, water's flowing this way, it comes in and forms turbulence, and so that wall actually falls in and it will actually gradually move upstream. And as it moves upstream, because where those dredge pools are, as I showed before, the river banks are technically steeper because the bed's down here rather than there, you actually can have riverbank erosion just moving gradually upstream. And this happened classically in the Hawkesbury. So upstream of about Lower Portland, all the way to Richmond, was dredged for the sediments, for the sand to make Warragamba Dam. And so there are pictures pre-World War II of people at Windsor, which is a deep river now. You can take boats all the way to Windsor, but kids used to ride to school along the riverbed. It was basically shallow water over sand. All that sand's now gone to Warragamba, and so the dredge pools were so deep, there's catastrophic riverbank erosion all the way along the Hawkesbury. And those sediments in the Hawkesbury are not like here. They're fine silts and they're beautiful soil, which is why there's all the turf farming there. And that's much more vulnerable to slumping and erosion. Fire has changed rivers as well. A lot of agricultural practice and also a lot of just general fire management has meant that there's more fires reaching river banks. And a lot of evidence, whether it's spoken evidence from Aboriginal communities or also early anthropologists, but also ecological evidence, Aboriginal people tended to burn away from riverbanks. And so the riverbanks tended to be not burnt that often, only with wildfire. And because of that, riverbanks in this part of the world tended to be rainforesty and sort of refuges in the landscape. Nowadays, fire reaches the riverbanks much more often. There's a lot more grass, which is flammable, and so summer fires will often burn down into the riverbanks, and also a lot of landowners will just burn the banks because they like burning the banks. Pest species is a major form of degradation. We talked about weeds before, and weeds are probably the major challenge for riverbank restoration. But in some parts of the world, rabbits are another big problem. And also there can be native pest species. In some areas, wombats can cause issues. They're a native species, but in the unbalanced environment that we have, they're causing problems. Pest species tend to become pests because they more easily and readily adapt to the changed conditions. So that they exploit the degradation, and once they're in, they keep that degradation occurring. They degrade the system further. Nutrients, big problem. I talked a bit before about nutrients being mobilized because of more water coming in, but also you can see patches like this farm across the way. They're obviously putting, it's nice and green, so probably nitrates to keep their grass green. Now, on sandy soils like this, yes, the grass is taking up some of the nutrients, but in sandy soils, a lot of it's just going to wash straight into the river. And with nutrients, it is the thresholds of the amount of nutrient, the amount of light, and the amount of heat end up getting algae blooms. This kind of degradation, all these factors together, have resulted in what we see here. Now, is it possible to restore? Possibly. One thing with any sort of land care restoration programs is that your aim has to be realistic, and there have been many cases of land care groups losing momentum because they want to achieve a gold standard, but it is impossible to do that within a human lifetime or within the resources available. So a little bit later, I'll talk about setting realistic goals. One thing that's happened, also I didn't mention it with the clearing, is that a lot of rivers on the East Coast, and the Hunter included, had well-formed levee banks. So when there are floods, the water flows faster in the center of the river than it does on the sides. Rivers also flow faster on the outside bends, but I'll get into that later on. But in floods, there's high velocity in the center, lower velocity in the sides. And what that tends to do is it moves sediments uphill. So sediments in the middle of the river are going to get pushed downstream. Sediments on the side can get uphill and then settle out. And so the natural systems in a lot of rivers on the East Coast, including the Hunter, is you would have had the riverbed, we have water level there, bank, and then a levee bank, and then going down into lower land behind the levee bank. So basically it was like a wall next to the river, like the levee around Maitland, but just natural. And what those levee banks did was any time they're overtopped, you've got a wetland forming, a billabong forming, and that water stayed in the landscape longer. So that water would gradually seep down through the soil and replenish the rivers. Now, with the clearing and with cattle or with earthworks, we've destroyed those levee banks. So water now, when it floods, it goes up the hill and then flows straight back down when the water drops. So as it drops down, it's pulling nutrients and sediment from the hills back into the river, but also it means that the landscape behind is drying out faster. And also means that in dry conditions, the river's drying out faster. So instead of having these lakes on the floodplains gradually seeping water into the river so it can keep on flowing, all that water's straight back into the river after flood. It flows out, it doesn't rain, the river dries up. So a lot of catchments now, especially in the upper catchments, the rivers are much more intermittent than they used to be pre-European. And one of the objectives of a whole of catchment restoration is to reintroduce the hydrological cycle. One of the ramifications of the degradation of the clearing, the change in land use, is that we get quicker flows downstream, as I mentioned. We also get higher downstream floods. So the possible maximum flood hasn't changed. That's the highest level of flood you can possibly get, but we get higher floods more often because water's flowing downstream more quickly. And so water gets out of the landscape down to the lower catchments faster, which means the water rises faster and can often stay longer. There's been some interesting work done in Europe around floods, especially in the UK, but also in the US, where they do significant revegetation of the landscape, not just the rivers, but also the broader landscape in the upper catchments. And it actually drops the flood levels downstream significantly. So instead of all the water getting down in 10 hours, it might take 30 or 40 hours to get down there, which means the floods don't rise as high. They might last a bit longer, but they're not as devastating. In areas like this, what this degradation has done is also changed the soil. If we look across here, we see sand, sand, sand. There's a couple of patches that look like they've got a bit of organic matter in, but it's pretty sandy soil. Now, again, pre-European, I talked about how riverine vegetation moderated the impacts of floods. They also stopped the finer sediments, the silts and the clays and the loams from washing downstream. They held them in place. What's happened now with the clearing of significant vegetation, every time there's a flood, these banks get reworked. The sediments get washed around, and the finer sediments, the loams, the clays, the silts, which are the things you really want for rich organic soil, they wash downstream. And so what you're left with is the heavier bits of soil, which is the sand. And a challenge for you is going to be re-establishing the vegetation so it can start capturing silts and loams and silts and loams and clays that are washing in from upstream. So through time, the riverbanks could eventually become good, rich soil again. Because it's going to be very hard to establish, say, rainforest on pure sand. You're going to have to work through time to actually build up the ability of the ecosystem to modify itself, to modify the ecosystem. And I think part of the demonstration today is putting organic matter in with your plantings just to kickstart that process. Another thing that we've lost with the change system is woody debris in rivers. Now, pre-European, we see a few trees in here in the riverbed, but the early description of the Hunter and the Hawkesbury, the Karua, all the rivers in this part of the world, was that the river banks had lots of fallen trees in. Now, they're important for a number of reasons. They're important for fish habitat. Most fish, especially the larger river fish, like hanging out under fallen timber. You lose the fallen timber, you lose the fish. But also fallen timber plays an important part in stopping toe erosion, the toe of the bank. If you look across the river here, you can actually see the toe, the very bit of the bank that touches the water, in a lot of places is slumping and eroding. Having fallen timber mitigates that process significantly, because what it does, the timber stops a lot of the incidental wave action, and that wave action is what causes a lot of that toe erosion. So having trees just sort of like in the water there, it acts like a bit of a wall to stop the energy, and that allows for sediments to accumulate behind the fallen timber, allows for reeds to grow, and reeds then stop erosion to a large degree. We did a survey in the Hawkesbury, and we looked at areas of slumping riverbank, and we found that there was a really strong correlation between fallen timber, which would allow for the growth of reeds, which would then stop the toe erosion, which would then allow vegetation behind the toe to establish and stop slumping. So most of the slumps on the river were where there was no fallen timber. So there was some interesting work done by a guy called Dr. Andrew Brooks at Griffith University. He did some experimentation on the Williams River originally, putting in what they now call large woody debris. He linked up with a couple of land clearing companies to get huge logs transported down to the river, and he would cable them into the bank. They put them in the water, attach them with cables to the bank so they didn't float away, and he measured what happened, and it did amazing things both ecologically and geomorphologically. So the fish came back and were breeding, and the vegetation was able to establish on the banks behind much more easily than other areas. And so there's now lots of programs putting in this large woody debris along riverbanks. There are issues. You do need to often cable it in to stop it floating away, because in floods, a lot of large woody debris hitting bridges can be quite damaging to bridges. But you know, it shows it is worth it if you actually want to restore, especially the aquatic ecosystem. Getting that wood in is critical. A statement about some logs going in just down the river here with those fish. Yeah, it's still a fairly more of an art than a science, but it's happening more and more. And one thing which, when I was managing the Hawkesbury program, was that it is expensive to get large woody debris, and it can be between $5,000 and $10,000 per tree to get it transported in and cabled in. So one thing I was encouraging in the Hawkesbury was to plant species that had a fairly short lifetime. So getting things like Acacia paramentensis, or some of the wattle species down by the water, so they only live for 10 years, and they will fall into the river and start providing that habitat. And by the time that rots, some of the other trees might be falling in as well. So you should be planning your banks to actually die and form form functionality later on. The question was, are there specific tree types or species that are better used for large woody debris? The answer is the longer the tree will live in the water, the better. So things like eucalypts and hardwood acacias, where you might get 15 to 20 years before it rots, will mean they have better functionality. So things like willows are useless because they rot after a couple of years, for example. But having said that, you've also got to be careful about the ramifications if it washes away. So it's something best done with professionals. But if you do have, so I wouldn't be encouraging you to cut down your few remaining paddock trees to drag down to the river, but there might be opportunities if a tree falls down in a storm, and you need to get it gone. there might be opportunities to work with the professionals to bring it down. Because I know that a large part of the cost of doing the large woody debris projects was actually bringing the trees on trucks down to the river and the cranes. So if it's local, it's going to be much cheaper. I kind of mentioned it before, but one of the ramifications of the degradation we've done to the river, so all this stuff I talked about before, is things happen faster. So when the whole landscape was well vegetated, you still got erosion. You still got levee banks forming and failing. You still got deposition. You still got trees falling in. You still had floods. You still had fires. You still had rivers filling up with sediment occasionally. But everything happened slower because all the trees in the landscape mitigate all those processes. And so what's happening now with the much altered landscape is things happen faster. Erosion happens faster and there's more erosion. Floods are bigger and last longer and happen more often. Fires are getting down to the river more often. Rivers are moving more often. So while a river might have meandered through a landscape in a 1,000-year cycle, they might be doing it catastrophically in a couple of 100-year cycles. And so things are happening faster, and because of that, a lot of the ecosystem, a lot of the plants and animals can't cope with the pace, and so they can't re-establish. So if you imagine 250 years ago, you had a big flood through here, and you might have got a slump in the river, on the riverbank. All the surrounding vegetation would have dropped to seeds. Those plants would have grown. The next half dozen small floods would have deposited, more sediment in there, and by the time the next big flood came through, that slump would have pretty much gone. Now, what happens is a big flood comes through, you get a slump. There's no trees around to drop seed in it. The next flood comes through and scours it out even more. You might get it eating back up the slope like this one here, and eventually you end up with sort of catastrophic failure. So getting nature back in is one way to slow down the processes again. The difficulty comes with rivers. You are subject to so much that's happening upstream. That you have some things within your control, some things within your influence, and there's a whole lot of stuff that basically you just got to pray to the gods that it doesn't happen. Probably all I want to talk about the degradation. Are there any specific questions on that section? The question is, by planting in behind, would it slow down the slumping process? It's more complex when you do have a slump already in place, and especially one with such a steep head wall as this, that what you'd be wanting to do is to plant not only uphill from it, but also in the slump and next to the slump. So what you'll be aiming for eventually is that steep slope becoming like that, the slope here being like that, and so when water flows in during floods, instead of hitting a solid vertical wall and causing turbulence, it will flow in and out. And then, and hopefully smaller floods and getting vegetation in there will gradually build the sediment back up again. So slumps like this, 20 years ago, they would have got a Cato in and smoothed it all out or filled it in and then smoothed out the bank. And you can still do that, but that is very expensive and it can also fail. Doing the soft approach is probably an order of magnitude cheaper. And it needs a bit more land and it's going to take longer to restore itself. But a lot of ecological restoration, geomorphological restoration, is setting the site on a trajectory. It's not actually getting the end point now. It's setting it into a point with the minimum amount of work, because there's always something else to do. Doing the minimum amount of work so it's on the right trajectory, so that over time it restores, recovers, reforms. And so that's always my suggestion, is you want to do the least work possible to get the long-term outcome you want, because it means instead of spending all your money and time on one place, you could do 10 times the area. Question is, should you plant trees? And the answer is yes, uphill and either side and in the slump. And in the slump as well. But also, one of the difficulties with revegetating riverbanks is that the weed burden is significant. Every time you get a flood, you're going to get more castor oil seeds. You're going to get more Tradescantia, the wandering dew. It's going to be hard. So, but what you need to get in is the native plants that can actually aggregate sediments. So things like Lomandra and the native tussocks, the cyperus and the sort of tuftier plants, because they, through time, will collect windborne sediment. So basically, as dust goes on, they collect them. You often see with a lot of the tufty plants, because the leaves are all stuck up like that, wind will come in with dust, the dust falls down, and they eventually form little mounds. And so the next one that germinates will actually grow higher and higher and higher. So you can actually rebuild landscape that way. Takes a while, but it will happen. Same with Lomandra. Small floods, turbid water with sediments in, will hit those. Sediments drop out. So every time you get a little flood, you might accrete another 2 or 3 centimeters. And so, over time, it's that trajectory idea. It's you need to keep an eye on it to make sure the trajectory is still going, and that's why monitoring is important. But I think things like this shouldn't be scary. Love your erosion. Learn to love your erosion. Aggregate sediments. So basically, native plants that through windborne dust will gradually build up, and you've probably seen it along even in Newcastle, where they've planted Lomandra longifolia in the median strips. It often builds up. You can actually see that all the dust that's blowing around the place, that they end up being above the level where they planted them. And plants do have that ability to actually build up the landscape. The other good thing about the tufty plants, and I'm jumping around a bit here now, but the good thing about the tufty plants is during floods, what they tend to do, if you've got all these the leaves up, floods come and they lay flat on the ground and they form a blanket. So they stop the water eroding the actual surface of the ground. So it's good to establish those kind of plants in these kind of slumps. So get your trees in. What I'd be suggesting in places like this, don't plant really heavy trees right on the edge, because you're going to lose these edges. Yeah, so you might put things like the wattles in at the edge here, because that's going to fall in 5 years' time, and then you plant your gum trees out here, because that's the angle of repose that you want eventually. You plant your gum trees 5-10 meters back there and plant other things that sacrifice plants in the interim. And then what will happen is as those gum trees grow and you've got a right angle of repose, those trees will drop seed in that, and you'll get trees growing on the slope. The question is, where can you get information about those causes I was talking about? If you go to Google Scholar, there's actually quite a lot of really good research, and it's in 2 areas. One is cause, looking at charcoal, so looking at fire history, and the other is palynology, so looking at pollen. So there's a few places where they've got some amazing data. There's been work done on Lake George down in Canberra, because that's a really long term, because there's so much sediment in that lake, and also Lake Bathurst. They can dig down a long way, and so they can get ecological history back, I think 30,000 years there. But also on the central coast around Gosford, in the sandstone, there's all these little swamps which have been there for tens of thousands of years, and so they can dig down and they can see the charcoal layers and also the pollen, so they know what the surrounding vegetation was like. So it's the palynology studies that is the main evidence to show how long Aboriginal people have been burning the landscape. And so when you suddenly get more grass and more eucalypts and more fire-loving plants, they know that the fire rates increase significantly. General wisdom is that fire regimes change through time, the same way that the technologies for hunting and gathering or living on the land change through time. The question was, can we use dead trees along the riverbank to create large woody debris in the river? So is it a good thing to do? The answer is sometimes. It depends on the species of tree. These ones across here are willows. So if you put those in the river, they'd probably only last 3 or 4 years. And also there's a possibility if any of it is still alive, you'll end up with more willows down the river, which is what you don't want. But also you've got to think about, will that tree actually have better habitat value on the land? So if you've got a big old eucalypt which dies on the riverbank, but it's got lots of hollows, that might be more valuable as bird habitat than it would, or glider habitat than it would be in the river. So you've got to think about the opportunity and how to take that opportunity. The question was, could we then put some of the dead stuff on the river bank? Yeah, it's actually in a lot of cases putting more fallen timber on the river can be quite good, especially if you've got water flowing from uphill across the riverbank, and having trees there acts sort of like a little retaining wall, and so you'll often get organic matter building up behind it. And if you're establishing plants, that's actually a good place to do it. So often is, and again, you don't want to lose it in a flood, and you don't want to have it falling downhill. So I think we're going to do a bit of a demo later on where we'll actually put some branches in and peg them in so they stay in place. So the question was, would it be better to move the fence back because of this slump? Bite the bullet and recognise you can't have a thoroughfare. The answer is ideally yes. Everything's a compromise though. If you wanted to restore, there's some really good science. There was a group called LERDEC, Land and Water Research Development Corporation, funded by the Australian government around the turn of the century. And they did a hell of a lot of research about river restoration. And there's some really good science, and it's been backed up by a whole lot of good practice. So people go back 20 years later and say, yeah, this worked. And there's some rules of thumb around corridor width or riparian vegetation width. Now, if you want to have geomorphological stability, so stopping the river from slumping, slowing down those processes, erosive processes, accelerating the depositional processes, so getting back to more natural banks, 10 metres back from the top of the bank is probably enough. Where there's catastrophic failures, you might want to go a bit further back because you've got to work out what the ultimate angle of repose is going to be. If you want full ecological functionality, so if you're wanting the river corridor to function for all the birds and animals that could live here, then on a river this size, it would probably be 50 metres from top of bank. Now, that's a compromise. A lot of people, especially when you've got 100-acre farms, that's a big chunk of your property. So a lot of land care is actually compromised in that manner. So you're looking at what is possible versus what is practical. But in this case, yeah, I'd be suggesting, maybe not moving the whole fence back if you don't want to do it at once, but actually doing a little arc out of there so you can actually have that slump process itself into a more sustainable size. For geomorphological functionality, you'd be looking at 10 metres from Stacey back along the whole length. And that would give you fairly good certainty that you wouldn't get more slumps once it's established, and that it would function as a riverbank, and over time it would end up not looking quite so bumpy and grotty, and you'd end up with a good lot of vegetation and a much smoother bank. But yeah, as I said, if you want full ecological functionality, you're planting up to halfway up the hill, which some people would do that. And some people could do that, but realistically, it's not going to happen everywhere. Advice about river restoration is averaging riparian widths. So there is a recognition that there are constraints and opportunities, and they say to get full ecological functionality, you want an average of 50 metres. But in any river length, you're going to have some areas where you might be more constrained, where you need access to the river, where there might be infrastructure where you can't go further back, but there might be other opportunities where you can go back 100 metres. And so it's that averaging out overall provides that habitat value. And it's harder here because it is such a modified landscape. The Hunter is one of the most impacted landscapes in Australia. It's one of the most cleared landscapes in Australia. If you look at the aerial photographs, there ain't a lot of bush around anymore. Yeah, it's a human landscape rather than a natural landscape. So you don't have the opportunity. So some rivers like up on the Williams, they've still got bush blocks all the way down to the river in some places. And so they could actually have corridors linking those core areas together, and that could vary in width and still have an overall functionality. Just wanted to finish up on the degradation. I think I've pretty much covered it, but so what we've got in the Hunter is we've got a river now that's got fairly low water quality. It's quite turbid. There's a lot of sediments carried in the water. There's a lot more nutrients. Temperatures tends to be higher. You have less woody debris. You have banks that are collapsing or reworking, and so it's generally an unhealthy river, even though there's still things holding on. It's always easy to build on something that's there than to reintroduce something that's gone. And that's both in terms of animals and plants, but also function, the geomorphological function, the ecological function.